Hello, Bain students. This is the second video of a series of 2 for our number patterns. This is number patterns set 4, 5, and 6. So we're going to start out looking at set 4 and pick up where we left off. As you can see, I created my table over here on the right-hand side. We have the number of trips going from 1 through 5, and then I took the information from the problem and I began to write it down on the right-hand side of my table. I quickly saw that my numbers were increasing in a pattern of 5 each time, so I was able to find that on the 5th trip there would be a total of 24 sharks. Once I thought about this for a little bit, I started thinking about what the relationship was between my first column and my second column, and how I could come up with a rule that would apply to every single trip. I landed on the rule 5n minus 1, 5n, n being the trip number, and then subtracting 1 from each product of 5 times n. Each time I did that, I was able to see a consistent product that would align with our rule each time. I'll do this last one just to show you that 5 times trip number 5, which is 25, minus 1 each time gives us 24. Okay? All right, let's go ahead and look at our second problem down at the bottom. This one was about frogs and trips. Again, I recorded my trip numbers on the left, and I came up with my sequence on the right. And you can see that my numbers are decreasing each and every time, and that I was able to see they were decreasing or subtracting by 4 each and every time. So I landed on 6 frogs as my answer for how many frogs would be on the 5th trip. Again, I looked for my rule going across, and I started to notice that I could do 26 minus 4 times my trip. So 4 times 1 is 4. 26 minus 4 gives me 22. 4 times 2 is 8. 26 minus 8 gives me 18. And so on, and it works each and every time, and I double check just to be sure that my rule is applying every single time, even down to my last one. 4 times 5 is 20. 26 minus 20 is 6. Okay, let's go ahead and look at our set number 5. Set number 5, number patterns. Again, my writing is off to the right-hand side. These problems offered a little bit of an added step here where we had to go far beyond just the 5th trip. If you were reading very, very carefully on each of these problems, it asked you to extend the pattern out to the 10th trip. So I couldn't just stop at 5. I had to create another table next to it that would take me all the way from 6 through 10. I did notice that each time my number was increasing by 6 every single time. So the number I finally landed on at the 10th trip was 63 worms, and my rule was 6n plus 3, and meaning my trip number. As you can see on my 10th trip, that would be 6 times 10 is 60, plus 3 is 63. Okay, let's go ahead and look at our second problem on this set number 5. We had to again extend our table all the way down to the 10th trip, and I noticed a decreasing pattern all the way down to 16 fish. My algebraic expression to show what was happening on the rule of my table from my left column to my right column, the relationship there was 96 minus 8 times n. 8 times n. N is our trip number, and it works every single time. I'll show you on our 10th trip. Actually here, 8 times 10 is an easy one to do in your head. We know 8 times 10 is 80, so 96 minus 80 is indeed 16. Okay, so now that I've done my set 5, I know that it is most likely on my last and final set that I will have to extend my tables even further, perhaps, than I did before. So let's go ahead and look at our final set, number pattern set 6. This particular sheet offered 3 different problems, and this first one had you create the table all by yourself. I set my table up to show that shows were on the left-hand side and number of people were on the right-hand side. And you can see that I labeled the sides of my table to be sure I was organizing my information. I went ahead and jotted in the information that the problem gave me and extended the pattern until I got all the way down to the 9th show. Again, I can't stress this enough, always reading very carefully to make sure you know what the problem is asking you. The 9th show had 4 people, just 4 people. And our rule relating the left column to the right column each time that works is 67 minus 7n. N being our variable of number of shows. All right, number 2. This one was about a roller coaster ride. I put my ride number on the left-hand side with my number of riders on the right-hand side. I did have to extend my table all the way up to the 10th ride according to my directions here, and I was able to get a number of 57 riders on the 10th ride, 57. I want to point out to you my rule that works each and every time is 5 times n plus 7. 5 times n plus 7. Okay? And then this last problem was even a little bit more difficult. It actually added in a 3rd step, which the others did not have. I had to make a table and fill in myself all the way down, look for my pattern. I did get that there were 24 caps all the way up to the 6th hour. However, when I was looking for my rule, I found that my rule was 4 times n. 4 times n. So 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, and so on. So my rule is pretty straightforward. However, look at my 3rd step. It actually asks how many crazy caps will they give away in 6 hours. Notice it does not say the 6th hour. It says 6 hours, meaning they want us to take the caps sold in the 1st hour through the 6th hour and find a grand total of how many that would be over the course of 6 hours. We're looking for a cumulative total there. So I had to take each of my cap amounts and create an addition problem and add them all up all the way across, and I got a grand total of 84 caps in 6 hours. 84 caps. Okay. Thank you very much for watching. I appreciate it. Take care. Bye-bye.